Hello students. In this video we will go over the steps outlined in lab exercise number 1. So you should find the instructions and the data, Excel data file in the course content in Blackboard. I'm going to bring over the Excel file. It should look like this. Lab exercise 1, this is your data. A couple things following along with the instruction sheet, plus a couple different things we're going to do. Now the first time you use either your own computer and every time you use a college-based computer, you have to go and add a data tool. I'm going to quickly show you how to do that. We go File, Options, way down here in this version, Add-ins, click Go, and then click checkmark that first one, Analysis Tool Pack, click OK. You'll know something's done when we have this data analysis function. We're going to be using that in the first part of stats, plus come back to it in the last part of the course as well. So let's look at our data set. One thing we're going to do first, it says in our first step, let's put our name in there. This is good practice, especially for a lab assignment, is to have your name in the file and as well as in the name of the file that you send me. First 3 digits of your student number. Let's pick this, and you'll notice that all the data is changing. Every time you go into a blank cell, press delete, the values are changing. So one thing we want to do here is highlight all your data, copy, and then without moving anything you want to go paste special, values. It basically locks in those values. There was a formula behind those values, but now look in here, it's just the numbers. Go into a blank cell, press delete a few times, making sure that none of the data changes. So that's listed in the first few steps of this. Now one step that's not listed on the exercise instructions, which may help you though carry out this exercise plus the material for the first lab assignment, is to name your data. So highlight all of the green cells, and we're going to go into Formula, Define Name. So I'm just going to name it my first name, Kevin. Go ahead and name it anything you want. I would keep it nice and simple and press OK. And I'll show you how that's going to save us time in a little bit. What we're going to do, because we want to have a larger area to work on for our calculations, is we're going to hide the middle 10 or 12 rows. So just click on those letters up there, right click, hide. Don't delete. We're just hiding them. So now you'll notice here we got column G and then nothing and then column T. All the values are still there. It's just that they're hidden from our view. Any calculations we make will still include those hidden values. So what we want to do is, in step 5, calculate the count, max, min, and then the range. So those things listed on the instruction sheet, the ones that are bolded and capitalized, those are Excel functions. Using Excel function is basically just putting an equal sign in front of the name, highlighting all your data. So we're going to use count. We're going to do the count first. So one way to do this is go equals count. It's going to count how many values we have. You can go bracket, highlight all the data, and then it'll come out as 420. Or what you could do is count, bracket, enter the name of your data, and you'll get the same thing. So we only need one of those. Max equals max. This will find the largest value. Equals max, bracket Kevin. I should warn you that if you've named your data something else, don't type in Kevin. You'll come up with an error. Be something my parents always told me. No, just kidding. It's all good. So we have the count, we have the maximum value, we have the minimum value. Now we want to get the range. The range is not a function. It's not capitalized on your worksheet. It is just a formula. A formula in Excel always starts with equal signs, and we can just go and highlight those two values. We want max minus min, the largest minus the smallest value, and we get our range. Our range is just over 19,000. Now, of course, when you're doing this, all your numbers are going to be different, except for the count. We're still having 420 pieces of data. The values are different because the values are all randomly generated. So don't be alarmed if your numbers are different. They should be close. We want to then, in step 6, calculate the optimal number of classes. Optimal number of classes, OOC, that is based on this formula. It's 1 plus 3.33 times, we need that shift 8 symbol in there, that asterisk, times log, in bracket. We can click on 420, or you can just type in 420, and that will give you a value of 9.73. That value should be the same. Now, if your Excel didn't have extra decimals showing, you would have a optimal number of 10, but if we just go ahead and increase the decimal places, we'll get that full value. It doesn't matter how many decimal places we have here, because this value is only used in the next formula. So optimal class width is the range divided by the optimal number of classes. So we should get a range of, I'm getting range of 1952. You're going to get a slightly different optimal number of class, or optimal class width. It could range from anywhere from 5 to 600 to 2,500, I believe, based on what the numbers are. So what we do with this number, remember in class, the optimal class width, it helps us determine how many, or the size of the classes. So this is telling me that the optimal class width is 1952.355. I'm not going to use 1952.355. As it says in the instruction sheet, step 7 is to determine a class width to the nearest hundredths value. So I'm going to go here, class width, and the closest hundredths value is 2,000 for me. If this was 1948, I'd pick 1900. So I'm glad it's a nice even number, 2,000. Going through the rest of the instructions, we want to basically create a data table, and then use Excel's histogram function or tool to help us generate a histogram for this data. So we're going to create a data table. In step 8, it's telling us where to start here. So we want to start at our minimum value. My minimum value is just over 10,000. My class width is 2,000. I'm just going to type in this so I have an idea what I'm talking about here. So I'm going to go 10,000 to under 12,000. Then 12,000 to under 14,000. 14,000 to under 16,000. This is what takes probably the most time in this lab exercise, 18,000. And of course I'm going to stop once I get to the maximum value of just under 30,000. So I've got a fair bit way to go here. So 20,000, 20,000 to under 22,000, 22. Of course, your class widths are going to have a different starting point than mine. It may be going up by 500, 600, 1100, whatever is the closest hundredths to your OCW number. And your starting point, you want it to include, your first class is going to include your minimum value. My minimum value is just over 10,000. I could have started at 10,900 and then gone up by 2,000. But because I'm going up by a nice number, I'm going to keep my starting points basically even numbers. Just makes it easier. Now, what we want to do in order to create a data table and a histogram is basically take all these pieces of data and determine how many are in each of these classes. We're not going to do that on paper because there is a large number of pieces of data here. So we're going to let Excel help us through this. In order for Excel to help us through this, we need to create a bin number. Not sure why that turned green. A bin number is only for Excel. So the bin number is exactly one value less than the upper limit in each class. So I could go like this. Your bin numbers are going to increase by the same increment. So I'm going to cheat a bit. I'm going to go basically creating a formula to go the above number plus 2000. Copy that down. And there is my bin numbers. Now in Excel, we go to the Data tab, Data Analysis, and we wait a second, and we want to go into histogram, that tool. Input range is all of our data. We've named our data. Bin range are those numbers we've created, and let's not include labels. And we want to create a chart output. Make sure you click on that last item there, chart output. And now we're basically done here. We click OK. It's going to take us to a new sheet. In time, there's a histogram. We're going to move this away. We're going to delete row 12. We don't need row 12. What we do is go back to our first, grab our classes, copy them, place them over these bin numbers, and so they appear in our histogram. Let's make the histogram bigger. Let's get rid of this frequency. Let's get a total here. Let's use in the Home tab this auto sum function, 420. The lab exercise states we want a percent, or we want a relative frequency and a percent frequency. Relative frequency is basically the frequency, absolute frequency divided by 420. Remember, if you're going to use the cell location to make that absolute. And the percent frequency is basically relative frequency, changing it to a percentage. And let's increase a couple decimal places there. Copying these down, we get that. We can do an auto sum for both of those, so we know that this is correct. So that is our data table. Classes, we can make that a little bigger. Frequency, relative, and percent. With the histogram, the only thing we need to change is to make this a true histogram by going into Format Data Series, getting rid of the gap width. So your columns all come together. We can add data labels on top to make it look like that. If we wanted to, we could highlight one of the columns and change color if something stands out. So that is it for lab exercise 1. Basically, this is what you should end up with in your lab exercise. You should have these functions and formulas here, and you should have a sheet that has your bin or your data table with the totals, as well as a nice histogram that looks like that.